Hi everyone, my name is Roxanne MacKinnon. I am the Urban Ecology Coordinator here at ACAP Saint John. We're an environmental organization based out of Saint John, New Brunswick, and we work on a whole slew of issues, environmental issues, anything from monitoring fish communities, climate change, to volunteer work with our community partners. But I'm here today to talk to you guys about my work. I work mostly in water quality issues, and I'm working on a very large project about algal blooms here in New Brunswick. So I'm here today to pitch you guys the idea of the water issue of algal blooms and eutrophication. And hopefully by the end of this presentation, you will know what eutrophication is and how it contributes to algal blooms and why together these are a growing issue in Atlantic Canada. So what is the issue? So eutrophication of our waterways are leading to algal blooms all across the country, all across the globe, really. These blooms are forming longer and larger. They're reducing our opportunities to get into our waterways and impacting our drinking water sources. Here in Atlantic Canada, blooms have been kind of on the rise, particularly in New Brunswick and Nova Scotia, which are two of our bigger provinces around here. I'm here today to talk from my work to kind of get that out to you guys. I am working on a very large project on the Woolastook or Saint John River here in New Brunswick. We actually found out in 2018 that parts of the river have benthic cyanobacteria mats. So these grow on the bottom instead of the surface green water like you see in the picture that everyone is used to looking at. So I'm leading a project looking at where those are and whether they're making toxins or not, and moving education into our communities about this issue. I won't talk too much about benthic cyanobacteria today because it's a new and emerging kind of issue here and we don't have a whole lot of research on it. I'll focus on surface blooms that people are more aware of, and you can see in this photo. So what is eutrophication? I've said this word probably 6 times now. For anyone who doesn't know what it is, it's a really big word with a really simple meaning. Eutrophication is the enrichment of our water bodies with nutrients, particularly phosphorus and nitrogen, which are needed for plant growth. These nutrients are being washed into our waterways mostly from human influences. So that can come from runoff from our lawns, agricultural land, forestry operations, more onto our own stuff. It can come from the improper workings of our septic tanks. Nutrients come from our wastewater treatment when you live in a city or a town. It also, if you're thinking of what you do at home, nutrients can come off of your lawn and gardens from using too much fertilizer. And also a lot of our cleaners have a lot of phosphorus in them that get washed into our waterways through wastewater treatment or septic. The real complicated thing with nutrient runoff is nutrients, when they run into the water, they can get stored in the sediment at the bottom of rivers and lakes and last for a lot longer than you would think. So they can be stored down there for years and be recycled back into the water, which means when you're thinking about nutrient reduction, you have to think very long term. You won't necessarily see immediate impacts by reducing your nutrient loads. They're going to come longer after you get that recycled nutrient out of the sediments. So what does eutrophication have to do with algal blooms? Well, algal blooms need those nutrients to grow. So when we're washing in more and more nutrients that they can feed on, they can outcompete other organisms that live in the water and form these really big blooms. So with the nutrients and the warm water temperatures that we've been getting and a few days of sunlight, you can get an algal bloom pop up fairly quickly. Here, thinking of freshwater, most freshwater algal blooms are actually cyanobacteria, which aren't an algae at all. They're a bacteria. They're also called blue-green algae, which you might have heard in the news. That's what most people call them. But they're actually a bacteria that look kind of like algae when they bloom. And in the marine environment, you can get things like a red tide that are actually phytoplankton that are blooming and causing all these problems. So together, those things are frequently called harmful algal blooms or HABs, which you might have heard of before. In the slides here, there's a linked video that kind of explains this a little bit more, and I'll link it into my references at the very end, and you can take a look at that if you need some more information. So why are they called harmful algal blooms? So they're harmful not only to humans, they're also harmful to pets and to wildlife. So they're called harmful algal blooms because cyanobacteria can produce various toxins. They can release at any point in time in their life cycle. So they can have toxins into your water that you're recreating in. So why is that an issue? If if you went down to your water tomorrow and it was green, you really shouldn't get in it because there might be a toxin in there. You don't know whether there is or not. So it's impacting your recreational possibilities. So you can't go swimming, you probably shouldn't boat through it, those sorts of things. And then it also has an implication on the drinking water side. A lot of people get their drinking water from surface water, so lakes or rivers or reservoirs. So if you have a cyanobacteria bloom within your water, if it is a toxic species, you may have toxins in your water, which increases treatment cost. And even if it doesn't, algae blooms can create taste and odor issues that also drive up the cost of treatment, whether it's your municipal water treatment or water treatment at home. And like I said, these toxins impact both humans, pets, and wildlife. So it can, for us, it can be anything from skin rashes to gastrointestinal issues to liver damage. And some of them are even a very potent neurotoxins, which you might have heard about the dog deaths that have happened from poisoning from cyanobacteria. The really tricky thing about a cyanobacteria bloom is that both the toxic and non-toxic blooms look identical. So looking at a bloom, you can't tell whether it's toxic or not. So it's best to just assume that it is. And you can send it out for testing. However, testing is fairly expensive and has about a 2-week turnaround. So you won't actually know for 2 weeks whether it is or not. So you still have to avoid your water body anyways. And now in terms of wildlife, the cyanobacteria blooms are they're photosynthesizing, so they're harnessing sunlight, so they're making oxygen during the day, they're using oxygen up at night. But the real main problem is when all of these cells die and they need to be decomposed. When they're being decomposed, that takes oxygen, so it can deprive the water body of all of its oxygen and will basically kill off anything that needs oxygen to live, so fish and insects that might be living in the water body. And you might have heard of very large fish kills. It's generally because all the oxygen has been pulled out of the water. So to kind of wrap it all up, I hope that you've learned why these are an issue, and that algal blooms are caused by the eutrophication of waterways. Those nutrients that are coming into our waterways are mostly being caused by human activities. That harmful algal blooms are on the rise across the globe, mostly due to increased nutrients coming into our waterways and our warming waters across the country. So all of this was hopefully inspirational to you guys, and you can understand why everyone can be impacted by an algal bloom if you like to spend any time on any of the beautiful water that we have around here in Atlantic Canada. And hopefully together we can come up with solutions to manage and prevent algal blooms before they occur, so we can come down to our favorite beach every day and be able to swim and enjoy its beauty. So like I said, I've put together a few references and resources that you might be interested in that kind of have Atlantic Canada context. First is Atlantic Data Stream, where you might find a lot of nutrient data for a bunch of organizations here in Atlantic Canada. And you can also contact me if you have any questions or you're looking for information that you can't find or anything at all. My contact information is on the very first slide, and I'm happy to help at any point in time. And lastly, I just want to thank the founders, supporters, and the funding partners of this challenge.